Okay. Hi, and good afternoon to everyone. Hope everyone is doing okay and having a great time. Um, so today we're going to be having a look at some introduction to credit risk analysis and modeling. So I'm super excited about this session because it will give us a look, I believe, into the banking world and how credits are, done and like the risk that is behind giving credit and what kind of model should we build, like everything that's related to credit, because for the most part I think it's closed uh, in our country especially. So I think it's really good. Plus yeah, plus it makes more idea, I believe. So if you have any questions, as usual, please let me know. You can raise your hands or just speak. Uh, I will be happy to answer. So can you see my screen, guys? Is it visible? Good. Okay, so let's get started. So first, let me introduce you to credit risk. So what does it mean, credit risk? So we already know what the word credit means, and we already know what the word risk means. So it doesn't take much to like try to come up with the idea what a credit risk could mean. So it just refers to the potential of the financial like the potential financial loss a lender or a creditor face if the borrower fails to meet their contractual obligation. So they already have. So when you go to a bank or other, like microfinance, or you may call them like a credit or loan offices, so you will be in a contractual obligation, or in a you will sign a contract that basically tells you like so I will give you this money, and you will have to pay me back by this time, or you will have to pay this much installment with this percentage of interest with the principal, and so on and so on, right? So that's the contract. So if the person that we are lending, so imagine that we are a bank and someone came in and like asked for a loan. So uh, if that person, if we give that person the loan and he doesn't pay us back, or of course it could be if that person didn't pay us back fully or even partially, or like in any way, could be could refer to credit risk. So it can be manifested as a complete default. So default by this context means that the person that borrowed the money is not going to pay us back. So this could be complete default, so which means full, like they won't pass fully, or it could be late payments, which could mean like if the person doesn't pay on the schedule, as per the schedule, if he is late or if she's late, and so on, and deterioration of their credit worthiness. So for the financial institution, which we are concerned more about here, managing this risk could be, of course, like uh, the the main thing that could determine their like existence as a whole, especially for banks or for any institution. They heavily rely on the amount of money they lend, right? So managing this risk could be it is crucial for profitability, influence on loan terms, higher risk, often mean higher interest rates and stricter conditions, while lower risk leads to more favorable terms. So for this example, if it is your first time taking a loan from a bank, like the interest, like the repayment time, like the window that you have to pay back the money, the conditions are more strict than when it's like your fifth loan, but you have successfully paid all four on time and fully. So that's what this line means. So effective credit risk management involves identifying their credit worthiness, assessing the situation, monitoring and mitigating potential losses. So you have to like first identify the loss, the potential loss, of course. For these kind of things, if it is too late, it's too late. Like it's not like you see it and you identify it. You have to identify it beforehand. You have to assess it, you have to monitor it, and like you have to try to mitigate the potential loss. So this will enhance decision making, whether or not to give that person like money, or to lend them some money, or even like after how much should we lend them, and how much or how long should we give them to pay back. So all these things are for decision making, ensure regulatory compliance. So there are some compliance that we have to like be in line with the FRAs, like financial obligations. And of course, the most or like equally important thing is building trust through responsible lending. This, of course, includes for your investors as well as for your, customers. So why is it important, like to do this analysis, the credit risk analysis? So the first one, of course, is to minimize potential loss, to help lenders make informed decisions, better enable better portfolio management and risk mitigation, increase profitability by enabling accurate loan price and competitive offering, support regulatory compliance, contribute to the financial stability as a whole, even for the country. Crucial for lending institutes or to assess their borrowers' risk. So one example, like a few examples, could be loan approval at the bank, it could be at a bank, credit card issuance. So we don't really have this. I think there was a start at some point, I think, from Dashan Bank or Islamic Bank, but I don't think they followed through. I don't know, like I'm not sure. But credit card issuance is very, very, very much dependent on this. Or okay, forget the card, but even credit issuance, for example, from Telebur. So if you have seen how Telebur like lends you money, depends on a lot of things. So um, for the first time you like try to borrow money, it may be like very low, but with time, if you repay on time or even before time, if you repay fully or not, or like these kind of things, pretty much like determines how much they are going to lend you, as well as by when, like how long they will uh, lend it to you for. And of course, buy now, pay later services. I don't think we have this right now in implemented in Ethiopia, but yeah, this also like you purchase. So for example, from Apple, if you have, I think Apple Pay, I think from is it from Apple Pay? I'm not sure, but if you want to buy Apple products, you can pay in installments within a year. So if it is like 1,200 for like a phone, you could just pay $100 per month. But of course, they have to take you through this process in order to see if you are, worthy or not. So of course, we have different types of risks, credit risk. The first one is, of course, the default risk, which is the risk that the borrower wouldn't repay the debt in full. Concentration risk is when you lend the money for a concentrated group, or like to a single counterparty or a group of related counterparties. So this is really bad, because if for instance, if we take an industry, if you lend all of your money to the wine industry, let's say the garment industry, it's a risk, because if the garment industry flourishes, you will get paid back and everything is okay. But if if that doesn't work out, you will definitely pay for it, because it's a risk. Downgrade risk is just the borrower's credit rate drops, increasing the borrowing cost. So this pretty much means if the borrower doesn't pay back in time, so therefore their credit risk is going to drop, and that means they will be increasing borrowing cost. So, and of course, recovery risk. So this is the risk or uncertainty about how much can be recovered after the default. So, for instance, an example for this one could be, so we all know the 5 C's, right? Like one of the 5 C's is collateral. Right? So let's assume that you're a bank and someone with a house came to you, and the house could be estimated around 10 million, and he asked for 11 million or 12 or 15 million, and you gave it to him. Of course, I don't think that's the case here, but just for example, so you lent him the money, and he couldn't pay us back. Right? So we go ahead and sell the house for 10 million. So that's what we have recovered after a default by selling, or by selling the collateral. So that's what it means. Country risk is the risk that a country as a whole couldn't pay back. It could be because of economic or political issues. I think Ethiopia has gone through a similar thing. I think very recently. So I think everyone knows example for this one. Yeah, so let's go through the key concepts of credit risk. So we will take a look at both the quantitative and the qualitative factors that accounts to credit risk. So the first one is, of course, the 5 C's. I think I was mentioning them earlier. So this is character, capacity, capital, collateral, and conditions. So what are they? So widely used framework for evaluating credit worthiness, of course. The first one is character. So for character, you see how, if they are consistent with their payment history. So this could be, you could see like their past history, if they have any history with your bank or with your institution. You could just take a look at their history, past history. How much did they repay? When did they repay? Did they repay on time or not? And so on and so on. So that's character. So is that person honest? Is that person does he or she have integrity, or are they real? And the second one is, of course, capacity. So this is is that person capable of paying us back, or is that person capable of generating the money to pay us back? So the ability to generate sufficient cash flow to repay the loan. It could be debt to income ratio, stable revenue, and so on and so on. And for the capital, their financial strengths or net worth, showing commitment in institution. So it could be a personal investment in a business, their house, and so on, or their business as a whole. Collateral, of course, I think we all know this term. So asset pledged to secure the loan, or a secondary repayment source. So it could be property, a car, and so on. And the condition, of course, are external conditions that could contribute to your, the condition that the person could not repay. So this could be like economic situation, the trend in the economy. So if that person is from the earlier example, if that person is from the garment industry, and if the garment industry is failing, that's an external factor. So they provide context, crucial context explaining why financial outcomes occur and what might happen next, complementing the qualitative data. So this alone is not enough, but it's just a complementary to the quantitative data. So what is this quantitative factor. So here we will see three main, and the fourth one is actually derived from the three. So the first one is probability of default. So these are just measurement of financial numbers that form the backbone of a credit risk model. So for the modeling, we are going to take a look at this data. So the qualitative are just complementary to this one. Okay. Yeah. So the first one is probability of default. It's just how likely the person to fail to meet the debt obligation over a specific time. So if the credit model predicts a small business loan has a 5% probability of default over the next 12 months. So this is so it has two components: the probability of default and, of course, the time frame. So this means that there is a 5% chance that the business will default within the year. Loss given default, so just an estimate percentage of the exposure a lender will lose if a borrower defaults. So I think earlier, I think we have seen an example about this. So if you like loan $100,000 for someone and they defaulted, but by selling their collateral, if you manage to get back 30,000, that means 70,000 is lost, or that's loss given default. And exposure default is just the total outstanding amount a lender is exposed to at the moment of default. So how much of the money is at default, or so for example, a credit card with $5,000 limit and the current of already $2,000 balance, the exposure at default can be higher than 2,000. If, of course, the current is 2,000, but if the person could draw more before defaulting, it could be more. But for now, at this level, it is 2,000. So the last one, of course, is derived from the three. So the three are the main ones. So the expected loss is just the multiplication of this defaults, which is probability of default, loss-driven default, and exposure at default. Okay, before we move to credit risk modeling, let me just check up from you guys. So how is it going? Is it clear, guys? Is everything clear? Is everything going good? Are you guys following? Okay, good. So is there any questions? Maybe anything that's not clear, or anything that you would like me to go through again? Yes, all clear. Okay, good. Okay, thank you for confirming, guys. Let's talk about credit risk modeling. So credit risk modeling is just simply a numerical value of credit risk, or like it's more like credit risk modeling is the use of statistical and mathematical techniques to quantify these credit risks. So just a numerical representation of the credit risk. So its method is to quantify the credit worthiness of. So we, of course, like, it's really hard to explain this, because either it's not implemented fully or it's not open to the public, because this credit risk modeling gives you a number, which is it quantifies your credit worthiness. I think for the Western world, I think they use a number from I'm not sure, from 100 to 800 or to 700. I'm not sure, but the higher you are, the lower like you are quality of a credit. Like if your number is close to 700, that means you're not going to get a good credit. So your credit score is bad. So they already know their credit score. So like it's very clear for them. But for us, I think most of it is not implemented fully, or it's not open to the public. Like you cannot know your credit score. I believe. Maybe if I'm wrong, maybe you can correct me. But yeah. So For modeling, so we have two types. So the fractional statistical method and the more modern machine learning models. So for the fractional, we have the logistic regression, and for the modern, we have, of course, here, of course, we also have, I think, scoreboard for the fractional, and for the modern, we have random forest and neural networks in the others as well. So why is it important to build a model for credit risk or credit risk modeling? So it improves the risk assessment and decision making. It enhances your portfolio optimization so that you will have, you can have a combination of like high risk, high return, credits, and like low risk, low return credits as well. So in order to have an efficient portfolio. And the more efficient capital allocation is also crucial. So let's talk about some of the techniques from both the traditional and modern machine learning models. So for the traditional, it's like choosing a model balanced with accuracy, interpretability, and regulatory compliance. So one thing you should, of course, for now, it's okay for this project, but I think we have also mentioned it in of course, it's not okay because I think we have mentioned it in the challenge document about the regulatory compliance. So we have to take a look at it as well. So for the traditional statistical models, we have the logistic regression and the credit scorecards. So I think we already know from the logistic regression, so it just predicts probability default for a binary classification. So it's highly interpretable. Coefficients are very much easy to interpret. I think we have seen how to interpret or the interpretability of the logistic regression, how we can do that with the coefficient of the features. It's computationally efficient. It doesn't take a lot of computational power to train it, and provides probabilities and, of course, regulatory grading because it's really easy to interpret. But of course, it highly assumes linearity because it's a tree. Struggles with complex nonlinear relationship without exclusive feature engineering. And credit scorecard is just a practical implementation of this logistic regression. So it's uses point system. So for where you initialize a loan or a credit, so it's used at the time of loan application to predict the likelihood of future defaults based on a static application data. Sorry. So this could be credit history, demographics, and deployment status, and so on and so on. And of course, we have, in addition to that, so the first one is application, and the second one is behavioral scoreboard. So here is just developed by using a dynamic data. The first one is, of course, static, which is gathered throughout the loan's lifetime. Sorry. So, for example, if the person pays on time, like their character, their payment habits, the transaction history, change, and credit utilization. So, are they using it well or not? To measure ongoing risk and adjust the credit limits of term. So, yeah. So behavioral, I think you can see it. I think with the example of Telever, if you don't pay on time and if you don't make full payments and so on, you could see how much they can reduce it. So the pros, of course, it's highly interpretable, easy to explain, implement, and it's widely accepted. Of course, it requires extensive feature engineering, manual feature engineering, and it's very much less flexible to complex patterns, which the neural network and other like modern machine learning models are capable of. Okay, so for the modern machine learning approach, we have the decision tree and random forest and the gradient boosting machines. Which are capable of capturing complex nonlinear relationships that are not easy to capture with logistic regression. So for the decision tree, it's just like a tree. At least I think we already know these models. So I'm just going to read or just highlight them. Okay. So if the income is greater than 50K day and age, of course, there is an example that there is some issues. So for the logistic regulation or for the three based, so if they start with the income, which means for income greater than 50, if one leaf starts from then, for that, and if age is greater than 30, that's greater than 13 also, and so on and so on. This could lead to risk because it's pretty much a linear relationship. So it's easy to understand, of course, the decision tree, since it's a decision like a tree-based model handles like mixed data, captures nonlinearity, and so on. Of course, but a single tree prone to overfit, and it's very prone to noises in the data. And typical binary outputs are what you would get, so it's not probabilities. So for the block box models, we have the random forest, and for the gradient boosting functions, I think. I hope you guys remember what the black box and white box models are. So of course, the random forest enables multiple decision trees, not just one. Output models are mean of individual trees. So it's highly accurate, handles large data sets, features, robust to outliers, and is also good for missing data. And also it's less prone to noise and overfitting, but it's less interpretable. You have to use explainability like tools like Sharp or Line, and it's pretty much higher computational like higher computational needs. And for the gradient boosting machines, it sequentially builds models to correct errors from the previous models. So it's seen as a state of the art accuracy, handles complex linear relationships. Of course, they are high in computational needs, and as well as highly prone to overfitting if not tuned. And of course, here elsewhere, they are a black box model, so it's less interpretable. Okay, so this is just model selection is a balance between accuracy and interpretability, because like in order to like interpretability here is very crucial, by the way, guys, because there are a lot of regulatories that you have to comply to. You have to have these explainabilities. If you don't, you cannot show how the model made the decision, which features contribute to what, and so on. You may fall to that. Okay, so for the data type, of course, mainly especially for our country, we mainly depend on the traditional type of data. But of course, there is also alternative data. Maybe, hopefully, in the near future, we will also add this. But I think they are not that easy, at least for the current system, in order to integrate it into the system. So that's maybe most probably why they are not included. But for the traditional, I think you already know, like the credit score, the payment history, outstanding debts, income, employment, demographic, age, like things like that. And of course, from the internal lenders file, you may see transaction history and repayment records. But for the alternative, so this type of data are really interesting for me, at least. I find them to be really interesting because these data are not from the conventional credit card, credit score sources, particularly for team files or creating visible individuals. So here, you may see the transaction data, Uh, so this could be spending pattern, utility payment, bills. So if the other person do not have like previous data, or of course on top of the previous data, you could also use this. So how much do they spend, and their utility or utilization. For telecom, utility, rental data, you could also get a payment history from here. You could also see if their character, do they usually pay their money on time or not. And for extreme data, website user behavior. So this is of course a long shot. Audio and text data that the customer may have from the calls, from the service calls, or from application they have submitted earlier, or before from a survey and questionnaire data. So these are really interesting. Of course, they could also be used for both, the quantitative and the qualitative factors, but more of I would imagine for the qualitative factors. So they offer opportunities, so expanding credit access, but also challenge lack of standardization, bias, regulatory concerns, and more interpretability. So, of course, they are not easy to get, as well as they are not easy to integrate with the current system. That's, of course, they are really interesting. There's for example, for Ethiopia, it could be harder to get, the traditional data, but like especially for older people, you could see at their like their telecom or their electric bill payment pattern in order to see if that person is like a responsible person, determine their character and their spending habits. So that's really interesting. I find it to be very interesting. So I just wanted to add this because it's very important to have EDA at the at the start of any, of course, data related analysis. So it's very important. It's a very important initial step, and really which helps us to understand the data, identify patterns that are not easily identified with just looking at the data, uncover quality issues, guide feature engineering, and so on. Of course, you could overview the data by using, by taking a look at the structure of the data, the data type, summary of statistics, which is what you get by uh, mean, median, standard deviation, quartiles, and the numerical rows. So, if you are working with data frame. It's just there is a data frame dot describe. I think you already know this. You can also see the distribution of the numerical values and, of course, the distribution of the categorical features, as well as correlation analysis, identify missing values, and outlier detections. So it's very important to do it. So I just wanted to remind you in order. That's why I just included it in here. I know you already have some, uh, experience with EDA, but yeah. So it acts as a proactive risk mitigation, preventing biases or errors from propagating to the model that could lead to discriminatory lending. Hey, before we move to like the workflows and some risks or things like that. Let's hear from you guys. How is it going? Is everything good? I think there were some writings. Here we take, let's say, black box and white box. I don't know anything about it. Yeah, I think Dagi has answered it pretty much well. Thank you, Dagi. I hope it's clear. Huey, Enoch. Um, so they will be shared. I think that's why you didn't find it. Uh, Enoch. So the slides are shared after the session is done. So since the session is ongoing, you couldn't find it there, but after the session is done, we will share it immediately. So yeah, just take a look at it then. Okay, so any questions, guys, before we move on to the last slides, to the last parts of the session? Do you have any questions? Anything that's not clear, or is everything clear? How is it going? Just give me some updates. Okay, I will take that as yes, it's clear. So let's talk about the rest of the slides, which we will work with. That is like the workflow of building a cruise risk model. So first, let's start. You have to start with defining the objectives and requirements. So of course, it's not only for developing, like credit risk models. It should be your go-to workflow or your go-to like first step when dealing with, like any type of issues or especially with coding. So the first thing is you have to understand, clearly state the business problem. What do you want to do? What's expected from you? What is, like things like that. And then align with the business strategy and risk appetite. So how much risk are we looking to take? And what is the business strategy that we have? So we have to align that with the problem, the issue, the business problem. And of course, you have to understand the regulatory requirements, which you have also stated in the challenge document. And of course, after that, you have to define what the success criteria and performance targets are. I think we have seen this on we have talked more or in depth about these criteria when we talked about model evaluation. So if you want to remember more, just go back and take a look at that. Of course, after we have identified everything, we will go to the data preparation, so collection of the data. It could be from internal or external data source. Cleaning the data, of course, handling missing values. It could be by removing them or inputting them. Detect or correct outliers and standardize the formats. It could be by standardizing it, scaling it, or normalizing it. And for the feature engineering, it's just like creating new predictive features. You could use aggregates, temporal features, or RFM, and transform existing ones with weight of evidence. And then, of course, if you have the data, and if you already know what you need to do, you can go to the model development. You have to split the data, choose the model. Of course, you have to do at least two in order to have, like some comparison, train the model, and do some hyperparameter tuning, and cross-validate by using, cross-validate by splitting the data into multiple subsets. And then after you have like your model that you want to work with, you will go ahead and evaluate it. I think we have seen these methods last time. What it means with accuracy, precision, recall, F1 score, sensitivity, and of course with ROC AUC. And of course, choice of evaluation metrics involves trade-offs. So these are the matrices or the criteria that we have talked earlier, and of course from the last session. So it's the trade-off. The one with the highest precision may not have the highest are recalled or may not have, like the fastest response or prediction time or training time, or it could be highly computational intensive and so on. So you will have to know, like, depending on like your company's policies, business needs. So if your company is more, like focused on time, if they want to be fast, maybe you could, like compromise some, maybe just a little bit of accuracy for you could treat it with making time and so on. Of course, that's not going to be the case with like lending and so on, but just from the higher or general perspective. So this also, of course, depends on the business objective and risk appetite, as we have said on the beginning of the workflow. Of course, after you are evaluated, you select the right model, you will go to deploy it, and after deployment, you have to periodically monitor it. So integrate the model into production by deploying it as an API endpoint, which you will do. Monitor the model's performance and drifts. So if there is a drift or a shift in the data, you have to, like check it, set alert threshold for significant performance degradation. If the performance of the model is degrading with time, you have to set a like threshold. So maybe if the model started with 98% accuracy, maybe your threshold could be 95% accuracy, and if it goes to 95, you have to step in and like make some adjustments. And you have to plan for periodic recalibration. So it could be retraining, recalibrating the model as the environment changes, and of course with the change of regulatory as well. Incorporate feedbacks from monitoring new data and business rules. So proactively monitoring safeguards against model decay is very important. Lastly, some of the challenges that are related to credit risk is, of course, the most or the highest is availability of data, or availability of data and data quality is probably the highest like challenge. The model accuracy and limitations, regulatory and market changes, and data and feature modeling are other, like challenges or challenges related to model risk modeling. Sorry, credit risk modeling. So that's it. I have included some references here, which you can go through. But yeah, that's pretty much it from my side. So the floor is yours. So how is it? Is it clear? Is there any questions? Is there anything that's not clear? Please let me know so that we can discuss upon it right now. So anything, any questions, or is it clear? I think that Dagi is saying it's clear. What about the rest? Okay. Okay. So let me take that. Okay. Let me take that as it's clear. So I will be sharing the slides right now on G Drive. So just be on the lookout for it. Okay. Thank you, guys. And thank you for joining and participating. Have a great day. Thanks. Bye.